Hi everyone. First of all, awesome conference, like absolutely brilliant so far. I think it's really cool. Amazing lineup, not just because I'm on it. And yeah, hope to have another TC Conf next year. So, sidechains are very dear to me because I'm working on testing some at the moment. Now, can you explain, because the original term for sidechains is a chain that pegs back to Bitcoin, for example. Now, there are many different types, many different consensus models. Can you explain what a sidechain is?
I think it might have been me that picked out the name for this type of thing, but it was a pre-existing name which had a very loose definition as some kind of related chain to a main chain. And I think some people would consider even Namecoin to be a sidechain of Bitcoin, though typically a sidechain wouldn't have its own native currency because then it's its own chain, right? So an altcoin with some platform features, even if it had a way to move coins in and out of it, may not be a sidechain. But I think you can also think about the peg differently from the chain. So you have chains, and some chains have mechanisms to carry other assets that are coming from other chains. And so you could have multiple pegs to a single chain, and the pegs could be going in different directions. So it's kind of undefined. But basically, it's more layer 2 technology is one way to look at it. And if there's no peg, then I guess it's technically a chain that can derive value from another chain through timestamping or anchoring and things like that, which is what Tom was talking about earlier.
Okay. And so what's the main advantages then of having a sidechain instead of using either a main chain or building another altcoin?
You go?
Okay, take it away.
So basically the idea is that as Adam said, you reuse some part of the Bitcoin blockchain. So instead of re-bootstrapping from scratch something that was very difficult to bootstrap, you leverage something which exists and works. The super loose terminology that Adam mentioned, in which everything is a sidechain, there was a funny article by Jess Stolfi. He's a troll in general, but this article is very nice. My coach is a sidechain because the term was a little bit abused over the years. And so in general, you reuse something. In the very loose definition, for example, of Namecoin, the sidechain can reuse the security of Bitcoin with the mechanism of merge mining that was criticized and could be problematic in many ways. So, for example, Namecoin reuses hash power from Bitcoin with merge mining, which can create problems. In the more strict, proper term of sidechain that Adam mentioned and the Blockstream paper basically made the kind of official strict terminology, is you reuse the financial unit, you reuse the monetary effects. So you don't reuse hash power, you don't reuse maybe not even code, but you reuse the most important part, which is the most difficult to rebootstrap, which is value. So the idea is that you create a new project, you want to experiment with your architecture, you don't recreate money from scratch. You create your project, but you leverage the already existent monetary effects of liquidity, price, and everything.
Awesome. And oh, sorry, Max. You mentioned merge mining. So it's one of the ways of securing the chain. Can you talk about any of the other different types of consensus and the way that it's secured to the main chain?
Yeah. Well, I will also probably start with some kind of attempt to define the sidechain, because actually the answer to your question follows from this definition. For myself, I tend to think about sidechains as anything that combines global consensus with a M of N locking of original Bitcoin assets. Why M of N? Because if you have N of N, you basically have not a sidechain, but a multi-party channel. Like 2 of 2, it's a Lightning Network channel. So can we name them sidechains? No. First of all, why? Because they don't need a global consensus. Because at the moment when you have the number of participants in some economical protocol is the same that the number of participants that are making a decision by a consensus, you don't need a global consensus anymore. You just need to reach the consensus amongst those players. But at the moment, when the number of participants that take decision about economical reality is smaller than the number of people who put money into some system, you need more global consensus to build something trustless or partially trustless. And that's where the actually sidechains appear. And if we are talking about any monetary system, as Giacomo said, it should be a Bitcoin. So what kind of global consensus? I would say that sidechain can use any global consensus it like, depending on what it tries to achieve. Because sidechains can be used for scalability, for experiments, for better or poor security for different reasons, for doing something in a more controlled way. So depending on what they try to actually implement, they need different forms of consensus, starting from merge mining or separate proof of work or BFT type consensus, anything that can suit their needs.
Cool, yeah, and you mentioned a federation is one way. There's merge mining, federation. Is it likely that we'll see a trustless two-way peg soon?
I don't know about how soon, because there are missing bits of technology, but there are a few different areas of technology that could enable this. I think the main thing people are worried about with so there's another kind of sidechain-like object called an extension block. So for myself, when I was thinking about sidechains, I was thinking about how can we innovate faster on Bitcoin or do more experimental risky things and have some security firewall and modularity so that people can, do some very strong privacy things with experimental crypto tech like snarks or things, and do that in a Bitcoin context where you can't put that in the main chain context. There's too much crypto risk, people wouldn't accept it, and rightly so. But you could make a module and apply that technology to Bitcoin inside the module and have that be fully trustless. But the barriers to doing that are, if you do an extension block, which means that, firstly it's a block size increase, but you could stop that. You could say it all comes out of one size budget. But never, and it does directly provide a security firewall around those funds. So the only people at risk if the crypto for some experimental privacy goes wrong are the people who opted into it, which is good. No more coins will come out of that sidechain than went into it. If something goes wrong, the first people out will get their money back, and the last people out will get nothing, or something bad will happen like that, right? So that places the risk in the right place. But there are other problems because it's a consensus system on Bitcoin. One of the new novel security properties that you get from consensus system is that it's very fragile to forks, to accidental forks. Like there was one in Bitcoin's history where a third-party dependency, a crypto library that's since been removed as a risk, had different behavior on 32 and 64-bit systems, and nobody had noticed in a decade of this library existing. But that would be enough to fork a Bitcoin network, so it was fixed quietly and then described later in a vulnerability report. So if you imagine somebody's doing a bunch of experimental crypto stuff in an extension block, that would easily fork Bitcoin by accident. So we can't have that, right? So your next question is, well, how do you prevent that? So one approach is snarks. You use snark-like things or bulletproof-like things where the program you're proving correct execution of is verification of the entire sidechain's blocks. But that's an enormous proof, and all of the current proof systems are orders of magnitude away from being able to do that, and some of them make experimental security assumptions. So maybe the bulletproof like security and scalability will improve enough, and then we can make general, fully secure sidechains just by having the main chain block verify a list of them. That would be very nice. The other thing you could do is something like simplicity, which is formal provable blockchain extensibility language for Bitcoin, which we're trying out on Elements and Liquid. We did a developer preview release for Elements in the last month. And with that, you have enough guarantees of determinism that you could implement the sidechain rules in simplicity and verify it in Bitcoin and be pretty sure that it's not going to diverge. But you still got the size argument.
Okay. And Tom, so there's obviously, Lightning's one way of scaling Bitcoin, and sidechains, pegging with LBTC is another. What do you think? Are they in competition, sidechains and Lightning, or do they do completely different things? Do you see them?
I think they can do completely different things. I mean, at the moment, the sidechain can't be trustless and censorship resistant. Lightning can. But then there's things you can do with a sidechain that you can't do with Lightning. And like certain privacy, like confidential transactions in Liquid, for example. So I think they are very different things. I think that, yeah, Lightning basically maintains that censorship resistance, that trustlessness. But then, yeah, the sidechain can do more complex things. You can have more complex logic in a sidechain, more kind of smart contracting, if you want to call it that. So yeah, I think they serve very different purposes. Yeah.
Okay.
Another thing that Lightning cannot do very well is to manage situations of high liquidity requirements. So if you need a lot of liquidity slots, Lightning is intrinsically problematic, at least with two-party channels, while with multi-party channels maybe it can be better. But they can work together, for example, because a two-way peg, even if it's federate, for reasons of security, for example, from reorgs, must be slow. When you peg out or peg in, you need time because it cannot be fast, otherwise you have reorg problems. And Lightning can be a way to improve asset interoperability without waiting for the actual peg out. So if you have, for example, Lightning on Liquid and Lightning on Bitcoin, you can have faster and easier atomic swap between, for example, BTC and LBTC in the future using Lightning. So Lightning can connect both better.
Awesome. Adam, you mentioned before, I think, about that all shitcoins will move eventually to Bitcoin sidechains, or something similar. Was that? Can you elaborate on that?
Well, I mean, I think one of the interesting things about, well, I mean, in the history of altcoins, it seemed like there was a period where there were a huge number of them that had no features. And that played out, and then people started to need a new way to market them, so they added features. Some of them were real features, and some of them were stories to market. So it seemed like at least the feature direction could be achieved using modularity to Bitcoin, so people can add new technology inside the Bitcoin framework. But that does leave the second question is, well, where do they get the free money from to do it? Because if you follow the money, the actual incentive is to get more money, not necessarily to innovate. Also, there's a few cases where they're trying to do both, but there's a lot of cases where they just want the money. And so sidechains are not going to give them free money, so they won't use sidechains. So that means this financial incentive will, of course, remain, but it will have less credibility because if you have a very easy to use extension mechanism for Bitcoin and samples of extensions that do something simple that you can build on, there's not really a good story about why you're doing it somewhere else. And a kind of analogy, I think, other than sort of friction of having lots of floating value, sort of innovation without speculation, as it were, is that with internet technology, there were some competing network technologies, but it was pretty early on clear that TCP/IP was the winner. And yet in the crypto world, there's Bitcoin, which is kind of the TCP/IP, I would argue. I think that's more apt than people like to admit because they want to promote their coins. And I think the internet would have been similarly distracted if everybody was, making forked copies of a TCP/IP stack with, just change parameters like 1600 MTU, it's better than a 1500 MTU, and lots of crazy stuff like that because they were able to, I don't know, like claim ownership of all the IP addresses in it or print some money and would create lots of interoperability and friction. Now, of course, TCP/IP actually got routed through other things, right? X25 networks, all kinds of things. It still does, different technologies at lower levels. But I think that just economically, it's going to make a lot more sense and it's going to be a natural outcome. So, I mean, people talk about the Bitcoin dominance index, which got to a low about, 35, 40% at the low. But that's not volume adjusted. And that was at the height of the kind of altcoin mania. and it's now more about 65, 70%. And if you volume adjust it and you remove the things that aren't even coins, like shares in projects, stable coins, which are even inside the dominance index, which makes no sense, it's more in the high 90s. So I think that, to me, that means that it's already done effectively, right? You know, people are innovating, some people are still trying to raise money. Raising money is fine. I would argue that you should give some financial benefit rights to the investor. That seems reasonable to me. But yeah, there's lots of innovation happening. So I think the sidechain concept could be more general too, because generally what we're talking about is building layer 2s that preserve the security, the unique security guarantee of layer 1 proof of work mining into new application areas and into different trade-offs. So there are more of them, and it's still evolving. Like Sidechains by Ruben Sumson was a pretty recent proposal. It's an idea phase thing. It's somewhere between Lightning and a sidechain, and there are lots of different variants of sidechains. So I think there's scope for more such things, and new things haven't been thought of yet. So I think it's very, very quickly evolving. Probably a big issue is the wallets and standards and interoperability catching up, even though it's largely Bitcoin related. You know, even in the Bitcoin space, the features are not always usable. Like, you know, having a wallet to support a particular kind of contract, other wallets won't be able to co-sign it, for example. So there's recent efforts like Miniscript and PSBT to make that generically usable, but you know, that kind of work is lagging behind by several years from the bleeding edge of new things people are building. So I think, you know, building new things is great, but there's years of interesting things to come, and wallet support and interop for all these things will come in time as well.
And recently, I think it was like yesterday, the IRS released guidance on airdrops and forks, or a couple of days ago. How do you think that will, Maxim, how do you think that will, Jacobo? How do you think that will impact, so that the regulation will impact sidechains specifically?
Financial regulation is about financial assets. So when I say that a sidechain allows you to not try to rebootstrap an economical system, I don't only mean that your chances of success are better because you are not reinventing money, and your incentives are better because there is not free money attracting scammers, but also from the regulatory point of view, at least the financial assets you are playing with is already also has an already established stack of regulatory decisions. So I personally, I don't think that Bitcoin cares about anything of this. So if your project leverages a Bitcoin unit, your project will probably be more centralized than Bitcoin itself. So you should care what the SEC thinks, for example, or the IRS or everything. But compared to, for example, a fork airdrop where you create new financial, so the decision basically was interpreted as something like saying, if you own some Bitcoin and somebody creates an altcoin and airdrop the altcoin to the one-to-one, then you have to pay taxes for this kind of generated revenue, even if you don't actually sell it, even if you don't even know that it exists. So that's something that with the sidechain you avoid completely, because you are not playing with new financial assets. It's better from an economical perspective, technological perspective, because it cleans up the incentives, but also better from a regulatory perspective, because you are not you're not playing with fire again.
Yeah, I was just to say something else about the forks. So the forks or airdrop phenomena, which kind of died down after a bit. You know, some of the users like it because it's free money and they can sell them and get more Bitcoin, and that's fun. I sold some myself, that's great. But on the other side, as a technologist, if you have a wallet like with green address, which is a 2 of 2 multi-sig wallet that Blockstream runs, it's a nuisance because now you have to do some development work to allow people to extract the forks, and that creates development cost, security risk, and there are actually users who lost their actual Bitcoins by trying to claim forks. You know, and the fork might be like 1% of Bitcoin, so now they lost 100% Bitcoin by trying to collect 1%. So it's not without cost, and it becomes complicated, increasingly complicated, as funds are used in layer 2 systems. So how do you claim the fork that's locked in a Lightning contract? How do you claim the fork that's pegged into Liquid? I mean, when it's pegged into Bitcoin, into Liquid, we don't even know who owns the coins because they're all confidential, for example. And the same for other layer 2 things. So it's just friction and a nuisance for any kind of technical progress, I think, unfortunately. And they tended to be like fairly incompetently run, to be arguing about and making changes like a week before going live. And then users would come to exchanges. That's another pain point, right? All the exchanges had to manage the forks. So it's enormous cost. So at some point, I think the people doing the development just get sick of it and say that this is costing us more than the entire, collectively, like all the developers and exchanges, costing them more than the entire fork's worth in like developer hours and risk.
And Tom, about forking sidechains, what happens when a fork happens? So say Bitcoin splits into Bitcoin DEF or whatever, and how does the sidechain know? Is there?
Yeah, I guess this is following on from Adam's. But I mean, I don't know what if kind of Liquid Federation members have a policy on what to do if Bitcoin does split again into a fork that has significant value. Then there is a big question again, what happens to the forked coins that are pegged into the sidechain? So in that case, I'm not quite sure whether the Federation, I guess, just pegs out in both chains. Basically, you just replay, and then everyone who pegs out gets both of the forked coins. But I guess there might be some implications to that. It might become quite complex. Yeah.
Thanks, Tom.
I mean, it's a problem for all kinds of things. So, the HSMs, the consumer HSMs, like the hardware wallets, they had to handle forks like Ledger and Trezor. And, I think at some point they were getting reluctant to handle more than the first two because it's just too much risk. And you'll bear in mind that some companies, like LedgerX, for example, I think, has HSMs. A lot of the companies doing different forms of custody or derivative contracts have HSMs with business logic in them. So they can't just bypass it all and scrap it. It's like months of work and risk, and the forks just think that they can like mix some hacky patches and release it a week before going live. That doesn't work for people who are managing, LedgerX, I'm sure they've got many millions of dollars worth of Bitcoin in Bitcoin call and put options of various durations, right? So what are they going to do? Like scrap all the call options, pull all the keys out, do some massive high risk operation. It's kind of crazy. So I don't know.
So I think what I'd like to know, Maxim, I probably should have done this first. I'm a bit backwards. This is my first panel. So Maxim, you work for Pandora. Can you explain how you're using sidechains or how you're intending to use them?
Well, the same way like anybody trying to use sidechains, it's first of all scalability, it's experimentation, and better privacy. So if you need to do something today that will follow these goals, as of today, you have to either build something on top of Lightning, which is also very challenging, or try to invent something better with the sidechains, which is also very challenging. So basically, it's not about building something in sidechains today. It's more like designing better sidechains, because today we have, for instance, Liquid, which does its work, and if we need to do something that can be done with a Liquid, it can be done with a Liquid. So there is no real reason of creating Liquid 2 or Liquid 3 or Liquid 4 next to that with another federation. So you either are using existing sidechain or you're trying to invent better one, which will take time, and it's a constant process actually. It's more about even like what Adam was describing with the zero knowledge. It's probably the best way to do the sidechains, but we are years before the day that it will be actually available for doing commercial products or something like that.
Yeah, I mean, the other thing for scalability of sidechains is that in principle, so people, like the technical people knew this, but it wasn't as widely known generally, is that Lightning you can consider it as a kind of caching layer for Bitcoin, but it's a caching layer that can sit across sidechains as well. And so you could potentially have a Lightning channel where one hop is liquid Bitcoin to liquid Bitcoin, another hop is liquid Tether to liquid Tether, and another hop is like Bitcoin to Bitcoin. Now, we at Blockstream, Christian Decker worked for a while and was able to get working a different like Lightning on top of Lightning on top of Liquid, so that you could make a channel that would move Tether, for example, right? So, from our perspective, you know, that's like, I mean, you can use it. I think it got merged back into C Lightning, so it's available people to do extend and try to do other things. The next step would be different channels with different assets, but it does turn your Lightning routing node from a routing node into a trading bot. So, you know, fortunately it's an atomic trade, so if you're touching something that you don't want to hold because you have no view as its value, you don't really care because the whole chain of paired arbitrage trades or whatever is atomic. But by doing a trading bot, you're taking a position. Like, who wants to, you know, sell one thing for another thing, unless they're doing the opposite thing on an exchange or something, which they could do. I mean, at least single channel things are keeping a position. They're not like going in and out of a position. So anyway, that's just to say that there is some combination of layers. So we were debating what to call. If this is like a layer 1. Like if Liquid is layer 1.5, because Lightning goes on top of Bitcoin. Lightning is layer 2, and it goes on top of Bitcoin, but it can also go on top of Liquid. And the RGB project is also talking about some kind of, well, maybe layer 3. I'm not sure. You can explain.
Well, yeah, I think that also RGB in a way can be done across things, but it's mostly a layer on top of Bitcoin that can be transmitted in the layer on top of Lightning. It's getting very complicated. So if you try to keep a consistent layerization metaphor, it's getting complicated. For example, Adam said that Liquid is a layer 1.5. I will rather use complex numbers and say the Liquid is layer I, and so Lightning can be either a layer 2 or layer 2i. But most of the people in the room probably is feeling fuzzy right now. So. Yeah, RGB is quaternions, that's a good point.
So can you explain what RGB is for those?
So RGB is basically it's very in the same line of the presentation that we heard before about defending blockchains. The idea is that having protocols like Omni, Counterparty, reusing the block space of Bitcoin to store metadata that can be interpreted by meta protocol in order to transmit different stuff is reusing Bitcoin, which is good. But is reusing Bitcoin in a very bad way for at least 3 reasons. The first reason is that privacy is already bad on Bitcoin blockchain, on-chain, and it's terrible on an on-chain asset because you have the same traceability with 0 anonymity set. Because let's imagine one US Tether on Omni. It's super easy to do chain analysis because you don't have anonymity set. Scalability is worse because you have a conflict between the people who want to use the meta protocol and the people who legitimately want to use the protocol. They are parasiting your block space, and you don't want that. So you don't want to give it the precious Bitcoin block space away. So the idea is mostly coming from Peter Todd, which I'm representing in the panel, and it was the idea of client-side validation. The idea is use Bitcoin only for what Bitcoin does great, which is a single-use seal, proof of publication, double spending prevention, and transmit everything else on a side channel, on an off-band layer, completely peer-to-peer. So I have to give you an asset. Instead of writing on Bitcoin, I give you an asset. I give you a signed, digitally signed document that gives you the asset, and I commit this document inside something in Bitcoin that can be spent once, for example, in UTXO. And as he explained, that can be done without using any extra space. So the idea of RGB started from that, but now we're working together with everybody in order to make it compatible and not redundant with what is existing. For example, why the RGB is a concept of how to commit stuff on Bitcoin. But once you have that, you can use confidential assets on that, you can use existence lighting on that. So we are trying to work together in order to have an interoperability stack that doesn't duplicate stuff uselessly.
And so on the metadata in the block on using Bitcoin blockchain, Tom, from Commerce Block, Mainstay is used to attest back to Bitcoin. Can you explain that and how that works?
Well, yeah. So I mean, this is trying to achieve the same thing, maybe in a bit more of a blunt way, by just going to a separate blockchain completely. But then, you can have asset-specific blockchains so that you don't, and you can compress basically the entire history into a single commitment. And actually, you can compress lots of different commitments from lots of different chains into a single commitment on Bitcoin. So you only require a kind of minimal, although you do require this stay chain. So you do require this sequence of transactions. Sorry, yeah, okay. So it's a different model, I guess, with different trade-offs. So you are actually running a completely separate blockchain, which may or may not be a side chain, depending on the definition of a side chain. Of course, you can peg in Bitcoin if you want to use for transaction fees in this like single asset side chain. I mean, what the one client we have is for a gold token, and in this case, we can actually pay transaction fees directly in the underlying asset. But for other things we're looking at, like kind of securities tokenization, you would actually want to peg in Bitcoin in order to allow people to pay transaction fees. So it's a different model.
Okay. And what benefit does it have? So in terms of proving the structure, is that what it's for testing back?
All you need to do is just proof that there's only one history of ownership of the token. So it is permissioned and centralized. That the block producer is owned. The block producers are controlled completely by the issuer. You may federate it for kind of fault tolerance, but essentially it's completely centralized. But this doesn't matter because it's a centralized asset anyway. What matters is the proof. What matters is the fact that when you have a token, you can prove that you're the sole owner of that token. And you can do that independently of the issuer.
Thank you. I was going to ask about one of the pillars of Bitcoin is the trustlessness part and decentralization. And sidechains generally have some form of centralization to them. How do the people who build sidechains get enough trust, that they're not going to lose their Bitcoin, for example? Adam, thinking.
So it's a bit harder with Bitcoin because there's no trustless peg at the moment. But for assets that are created on the sidechain, your risk with Bitcoin is that ultimately the coins are escrowed in some way, in a somewhat decentralized way. Either if it's merge mined, the miners collectively could take them against the protocol, or if it's in some kind of HSM assured multi-sig, somebody could go hack 2/3 of the HSMs and potentially take them. Probably the legal risk is worse, that the people operating the exchange feel obliged to shut it down and engage in some kind of arbitration about something that went wrong. But for the assets that are actually native to the chain, native to the sidechain, I would say there's no risk of theft because there's nowhere to peg them back to. Like Bitcoin doesn't want them, it doesn't know what they are, right? You can't take them back to the Bitcoin chain. And in fact, even though the federation model is nominally centralized, I'd say it doesn't matter at all, and that people are significantly misunderstanding the degree of trustlessness it provides. There was some early debate on Twitter, of course, about how trustless is it, etc. But I think people didn't understand. Every new technology takes people a while to digest and figure out its limits, basically. And also, its current deployed design may not be final, right? People have taken some shortcuts and done the first version, but they intend to do a next step which improves it. So the basic point is, it's a bit like Lightning with a reactive security model. You kind of trust the federation in a very limited sense, all its job is to move transactions forward, like define an order for completed transactions and not work backwards. So in Liquid, that's supposed to be a maximum of depth 2 is final, is the consensus algorithm. But if somebody hacked all the HSMs and changed that, the owners of the assets could snapshot the last valid chain. They're all running full nodes. They can agree on what the history was and just choose some new function areas, operate themselves, and move forwards. So in that sense, the asset owners own their assets, and there's nothing anybody can do about it. Another sort of incremental trade-off is the assets on Liquid are more confidential. So it's hard for things to get censored in the first place because you don't know what an asset is, or the ownership is in a Bitcoin-like model, so it's kind of pseudonymous. Like you see a list of addresses, but you don't really know which collection of addresses are owned by one person and things like that. So it gets confused pretty fast. So I think that helps a bit. It's a bit more centralized, but it's more crypto fungible. And the reason for decentralization is fungibility. So if you get higher basic fungibility, you can tolerate slightly worse centralization, I would say. Anyway, the reactive security model is interesting. So I think that's actually more assurance. And what you can do to make that more real is build more tools to help users to extract their assets from a system that's starting to go wrong and bootstrap them somewhere else.
I will just quickly add on that. So basically, if you asked what Pandora does in this regard, in regard of sidechain, I believe that with the current level of the technology for doing sidechains, we can't do them trustlessly, but we can mitigate that risk by creating interoperable technologies that allows you to move your asset from a domain to domain with the different trade-offs. So basically, we have better interoperability, you reach better decentralization and better trustlessness, like with the RGB actually, which should be probably in the future as kind of inter-Bitcoin sidechain standard that can be just adopted for free movement between Lightning Network, Liquid, Bitcoin main chain, and maybe other systems.
Just very quickly, the state chains idea that Adam mentioned is interesting in this regard because you are still trusting some entity that can be centralized or a federation, a fixed federation, but they cannot send the pegged fund wherever they want. They can only privilege one of the previous owner in a chronology sense. So they can mess up with chronology, basically privileging past owners, but not send that everywhere. So it's still a trust level, but it's very different and very interesting to explore.
And I think to closing up, if we were to do, if each person gives a 1 minute shill of the projects you're working on and what you're doing, and what's coming up for you in the future.
Okay. Well, so hopefully we're going to be launching our first actual asset-backed sidechain shortly, which hopefully will be a test of the scalability of it, and we'll see. So watch this space, and hopefully you'll see some gold on a sidechain, depending on the definition of the sidechain, soon. Okay.
So I work mostly about consultancy in the last 3 years now and trying to focusing on education because consultancy is boring, and so I want to teach especially. But as part of my job during the consultancy age was to try to help standardization of these tools and things around Bitcoin, and I still want to do that. And RGB is an example. It's not the only thing I'm working on, but the idea is to work on something that can help the ecosystem to identify good standards and good practices and to converge, to interoperate, not to fragmentate. So I try to create synergies, and that's still what I want to do.
For Blockstream we're doing lots of, I mean I guess the point is to build a technology like sidechain up from scratch is a lot of work, and it turns out that you also have to fill in lots of other parts of it. So wallets, hardware wallet support, exchange integration, libraries, and different trade-offs, multi-sig and single-sig. So we're just continuing to do a lot of those things, and I think more things are converging. You can use Liquid assets in a green address wallet now. You can use them in Liquid Qt. Maybe you can use them in Electrum, we'll see. So Commerce Block has done some work on Electrum using elements. So I think as you can use a technology with all of the parts filled in, it becomes a lot easier to use and a lot more fun, and we can see more network effect. So for Blockstream's part, we're just trying to be a neutral technology provider. I think it's a mistake for technology protocols to come with, be technology promoted by a given exchange or Bitcoin exchange or something, right? That's going to be difficult for other exchanges to consider using. So Blockstream is intentionally kept out of active trading positions and activities so that people can feel that by using the tech or building things on top of it, they're not buying into a competitor who's going to pull the rug out under them. So I want to see more interoperability, and most of it's open source in the Elements project, so get involved and try it out.
Our motto at Pandora Core Company is scaling the future. So we are trying to build layer by layer a technology that allows you to scale trustless economic systems up to building a trustless, decentralized, scalable machine learning solution. But before that, we have to build a lot of different layers. That's why right now I'm managing this intercompany project of RGB and related standards, because RGB is not just about assets, but the technologies like client-side validation, single-use seals, and even state history graphs. They can be used for rich state, full NAS, smart contracts on top of Bitcoin, which are required for many other applications. So I'm coordinating that effort that involves like maybe already more than 10 companies and participants.
Thanks everyone for joining, and yeah, I hope everyone's enjoyed it. And I think I should summarise that Sidechains are Ninja, and question.
Mike.
I mean, I think proof of stake doesn't work, so I'm the wrong person to ask about that. Well, I mean, a more serious answer also is that even if proof of stake could be made to work, I would argue it's an unattractive proposition because it's more similar to the status quo, which is money buys influence and grows influence. So, if Bitcoin had proof of stake, all of the coins would be owned by Satoshi except for like a few that were given to Hal Finney that he sold or something. So clearly you can't use a proof of stake coin to fairly disperse coins. And if you're not fairly dispersing coins, that sounds like a government, right? That they're printing money and deciding who to give it to, and then it becomes a matter of political favoritism. Are you friends with Vitalik? Do you get some early cheap coins? That kind of thing, right? So that's the direction of proof of stake. So it seems like a path back to the status quo. People tend to hold on to the previous era's ideas and want to reinvent them badly on new tech.
Yeah, I think that proof of stake can have, for example, a very interesting historical role when you study history of Bitcoin outside the hype of all the scam coins. You realize that proof of stake was one of the first ideas in order to manage double spending prevention in the second B-money proposal by Wei Dai in '98. So already in 1998 there was a proposal with proof of stake. Then the author realized with the other people that it didn't work. So I mean, altcoins are usually taking bad ideas from the past and remarketing them into a money grab. This is the typical modus operandi. So proof of stake is interesting because it was an idea, it was proposed, it was debunked, it was overcome by a more sustainable idea that was proof of work.
Yeah, actually I would say also that I don't know what proof of stake is, because basically there are Bitcoin fault tolerance consensus protocols known for decades, and there is a proof of work consensus protocols, and they serve different needs. Because if you need to have a censorship resistance, you have no other way than just to use a proof of work. If you need to build a decentralized database and name it blockchain and market it, you can use Byzantine fault tolerance consensus and attach a coin to that and say that it's a proof of stake, very advanced database with a coin inside of it. So it depends on the area of application you're working on.
Any other questions? Okay, Tom. Sorry.
Give my opinion on proof of work. Yeah, no, I mean, personally, I think proof of work was a paradigm shift, and I come from a physics background long ago, and I think that fundamentally proof of work can give you an objective state. Proof of stake can never do that. It's always going to be some subjectivity in the state. And so, yeah, I don't think you can replace the censorship resistance that you get from proof of work.
And question? Oh, you next, Max.
Yeah, my question is, keeping in mind that we will be able with Lightning Network to operate between different sidechains and also blockchains, it's not that dangerous in some point. Let's say that I have a double spend in other blockchain or sidechain, and then I just using Bitcoin, but I did some kind of trade, and now I am getting affected because the other double spend, not Bitcoin.
I'll try first, then I'll give you the mic. So the interesting point about interchain Lightning routing is that in theory there is just one party exposed to the system they are trading in. So let's assume that I have a Bitcoin channel with him, and he has a Litecoin channel with him. If there is a problem on Litecoin, my part of the trade is affected because everything is atomic, but the security is only the only people that can be affected is the people which is relying on that specific layer. If let's assume that, for example, we have, let's continue this chain, Bitcoin, Litecoin, and Bitcoin again to Maxim. We perform the atomic trade. Now Maxim has a closable Bitcoin channel with an updated amount. I also have another one with less amount. Everything happens to the Litecoin layer. Doesn't really affect the successful atomicity between me and Maxim. So we can, so they are the risking parties because they are using a risky layer. But if you are outside the chain of the risky layer, you can also have in theory a Lightning multi-hop transaction in which one transaction is done by a Google spreadsheet. The point is that you have to be able to hide the pre-image of the HTLC, but if you can do that, you can use very insecure middle hope, leaving the extremes safe.
Yeah, I mean, maybe just briefly, and then go to the next question for time. So I think what Giacomo said is right, and generally you want to be using the most censorship-resistant secure chain for your own interests. If other people want to run trading bots on higher risk, less sort of censorship-resistant, less final chains, they can do that, and that's their risk. So you basically take the risk you want to take. And even if you do a chain that is like liquid Bitcoin versus Bitcoin, the liquid Bitcoin is not quite as censorship resistant in some ways. In some ways it's more censorship resistant because it's more crypto fungible. In other ways it's less because the Federation might shut down in a huge exchange hack incident or something, and then you know, if the funds that were in the channel were involved, like, hey, maybe you lose on that trade because it gets undone ultimately or something. So you won't be on a final chain.
Cool. And last question to Max.
Thanks for the great panel. Could we consider digital bearer certificate servers that are packed with Bitcoin to be sidechains, especially considering the recent revelation of Scrypt, which combines DBCs with CodeChain to produce a M of N backed server, which according to Maxim's definition would be a sidechain?
I'm not sure what Squid is. Maybe you can explain it offline. But yeah, I think actually the state change shows this. But Blockstream, when we published the sidechain paper, there was a related concept mentioned in it briefly that you could have actually just a single server and have a way to unilaterally withdraw from it. And that sounds like similar to what you're saying, and state chains is a variant of that. So yeah, I mean, I think as long as you have the ability to unilaterally withdraw and enforce your rights, it doesn't matter actually, even if the chain you're using is a central database with a single signer. As long as you can say, you can prove to the main chain that you're the owner and that chain did something wrong, so you're the last rightful owner.
Yeah, that's why I mentioned that N of M plus global consensus. So I wouldn't say that centralized database is a global consensus. So, but you can extend the definition of sidechain whichever way you want. So I wasn't trying to propose some global definition of sidechains. I just said about some useful model that I use myself to apply and define how to distinguish multi-party channels from sidechains and other kinds of technologies.
Awesome. Right. One more question.
Hi. So let's start by saying I'm against the Bitcoin private hard fork because I want the assurance of the fixed cap. But if we'd imagine a Bitcoin private hard fork, are there advantages, disadvantages for sidechains? Are they still doable?
I don't think you, well, I mean, if it's a hard fork, you mean like an airdrop? Yeah, I don't know. I mean, I suppose it's some kind of dilution or inflation in a way, right? If there are hundreds of them and people ascribe value to them.
So everybody, let's say they switch to private version.
So let's assume we create a better infrastructure for Bitcoin. The sidechain can also be a way to switch to that in a seamless way. So not only a sidechain can be a modular way to test new things, but even if you find a new thing that works, you can have people assuming a trustless sidechain, assuming a sidechain that can be censorship resistant as Bitcoin and even better, then you can have people just opt in gradually. In this sense, even a proof of burn protocol will be, I mean, the best thing will be a two-way pegged sidechain. The second best, in my opinion, would be a proof of burn one-way peg. So let's assume that we find a better Bitcoin. If you burn one Bitcoin, you get one Sidecoin. It's one way, but it's nice because the more the demand, the economical demand moves to the new system, the more the supply of the first system is destroyed. And so the last man standing, he will sell the last coin at the same price in theory because you have decrease in demand and decrease in supply. So proof of burn is a second best, in my opinion, than the first best is two-way peg, of course. So if your experiment was wrong, the people can still go back, which is a nice feature to have.
Well, actually, maybe I'm wrong, but it would be proper to say that you need a UTXO structure to build a sidechain, basically. So it depends of at what cost you keep the privacy. If you don't have UTXO model anymore and don't have a scripts, to build a sidechain, you need to build N of M multisig. If you can't implement with the functionality of sidechain N of M multisig outside of UTXO model, you can have sidechains. If you can't, you can't have sidechains. That's all. Am I right, Adam?
Depending on your definitions, yes.
Well, I'm not sure if we understood the question actually, so maybe you should. Okay. Okay, he's happy.
In conclusion, sidechains are ninja. Lightning and sidechains will live along happily, and I think I finally got the answer that sidechains are better than Bitcoin SV, even with its gigamegs. Thank you very much.